Hello, my name is Ahmed, and today we'll be looking at the sea level equation. So, why are we interested in this? From coastal tides gauge and satellite data, this graph shows how much sea level has changed from about 1900 to 2018. Items with pluses are factors that cause global sea level to increase, while minuses are what cause sea level to decrease. These items are displayed at the time they were affecting sea level, and some of these items we'll be looking at today. So the inspiration behind the sea level equation comes from the fact that we look at a column of water with density rho that depends on x, y, and z. And we look at how the mass of that column of water changes with time as a derivative, which helps produce this equation. So the sea level rise is dependent on three terms: isostatic, steric, and isostatic. So the question we need to ask ourselves is this: what does each term represent? So the first term is called the isostatic term. And the isostatic term in this equation captures the influence of changes in the total mass of water on the sea surface elevation. This could be due to thermal expansion of seawater, which increases sea level without necessarily adding mass, changes in water storage on land, such as large-scale damming or natural reservoirs, melting of ice sheets and glaciers, which adds water to the oceans. So here's an example of that happening here. So the second term in this equation is called the steric term. The steric term refers to changes in sea level due to density variations within the water column, and this could be due to salinity. And salinity changes can happen in two ways. Freshwater influx from rivers and rainfall can reduce salinity, making the water less dense. In regions where evaporation is common, water vapor leaves the ocean, leaving behind salts that increase salinity and make the water more dense. Thermal expansion also happens where heating causes the water to expand and become less dense, leading to a rise in sea level. As seen before in the isostatic term, thermal expansion is what causes that term as well. So the question we need to ask is this: what is thermal expansion? So the ocean absorbs incoming radiation, and these molecules heat up due to that. They gain in kinetic energy and increase in motion. And due to this increase in motion, molecules start to move further apart, decreasing the density. So now the same mass of water will occupy a larger volume. The third term in this equation is known as the isostatic term. The isostatic term refers to how land itself moves in response to the redistribution of mass. And what is this due to? First of all, there's post-glacial rebound, and this is when the Earth's crust rises after being compressed by the weight of glaciers during ice ages. As the land rises, local sea levels drop relative to the land. And this is happening today in places in Scandinavia, such as Greenland, and also in places like Canada. The second reason could be due to tectonic activity, and this is when tectonic uplift changes the land's elevation, impacting sea levels. And this can come from movement of tectonic plates and volcanic activity. So, is there any practical ways in how we can measure sea level rise? So, one way you could do that is through tide gauges. And tide gauges work by measuring the rise and fall of sea level relative to the land. They are typically placed in coastal regions because these regions are where the effects of sea level rise are most significant. Measurements can be affected by local conditions such as a river nearby, which affects flow of water. And this is the equation that they typically use, where S is the sea level rise or decrease, N is sea level, and U is the land level. So there's a rise if N is greater than U, and there's a decline if N is less than U. And another way we can measure sea level rise is through altimeters. And altimeters use radar or laser pulses to determine the height of the ocean surface. These altimeters are crucial for looking at sea level and studying ocean dynamics. Unlike tide gauges, which are fixed to coastal areas, satellite altimeters provide global sea level measurements, including remote parts of the ocean, by making orbits around the Earth. This allows scientists to observe patterns in global sea level rise, ocean currents, and seasonal variations. You can also measure different things with different satellites as well. Down below is a picture of Sarasat, and this actually produced the first ever map of sea ice thickness. When we compare results with the altimeters and the tide gauges, there's a good relationship with R equal to 0.96, so there's a strong correlation between the two data sets. However, when you look at the data set of altimeters in coastal in the tide gauge locations, there are some areas where there isn't a strong correlation, and that is due to the movement is due to nearby water impacting the flux of water in that region. Well, thank you for listening.